Welcome. In this tutorial video, I will describe how you can subset data prior to the creation of EDA displays in the KIWI Explore module. KIWI Explore provides three different methods for subsetting data. You can provide a global data subset using R conditional expressions. You can filter that subset using predefined conditions. And you can also handle BLQ records in different manners, including excluding those records. The final data subset used to create the EDA plots and tables can be obtained by combining any of these three methods. I will now switch to the application. I have opened KIWI Explore for a dataset called subset_demo.csv. And this page is shown side by side with the profile manager, which was opened for this dataset. I will go over all three methods of data subsetting, starting by the application of a data subset or valid R expression. So I will start by showing a scatter plot of creatinine clearance versus weight. This is showing the entire data set without application of any subset. In the profile configuration, if you go to the data subset, you can see that this panel contains four different fields. The first panel, the first field is called Global Data Subset, and in the case of this first profile, this field is empty. For the second profile, which I called With Data Subset, I excluded the data between 70 and 100 kilograms. So the entire block of data is not being displayed. To request this subset, I had to provide a valid R expression in the data subset panel. And this expression was entered in the first field, the global data subset field. This expression reads as WTKG strictly lower than 70 or WTKG strictly greater than 100. This expression defines the sets of records that would be included in the EDA display. If you're familiar with R, this is a fairly simple conditional expression. If you're not familiar with R, the user manual provides some introduction to the creation of R logical expression or conditional expression. You can go to the Appendix 6, and this section of the Appendix 6 provides the list of test operators and Boolean operators that can be used to create conditional expressions. Some examples are provided in these tables. So I encourage you to read that section and learn more about how to create conditional expression that could be useful for your dataset analysis. Coming back to the application, I will now illustrate the use of the second method of data subset, which is more filtering method than a real data subset method. For that, I'm going to use the histogram profiles. The first histogram profiles display the distribution of time since first dose in our data set. So we have 1, 2, 3, 4 peaks of time since first dose. This is the default behavior of all the EDA profiles. If you go to the data subset for this all records profile, And if you look at data subset, the keep field is controlling the second method of data subset, and the default is to keep all the records that are defined by the global data subset expression. So if you don't define any expression, you're using the entire data set. And if you're setting the keep to all records within a subset, you're again using the entire data set. The next profile used a slightly different filter, and the filter was the first record per subject. And by doing so, I subsetted the data to the very first record per individual in the data set. So all my time since first dose values were 0, and you end up with this very square-shaped distribution. Going back to the profile manager, if you go to the data subset for this particular profile, you can see that I selected the keep field to, or set this field to first record per subject. When you open that field, this is a drop down that provides 4 different filtering method or filter definitions. You can select the first record per subject, the last record per subject, and two other filters that combine subject ID and a value of covariables. So all those 4 fields require that KIWI recognize what a subject is in your dataset. So this is done in different ways. The variable definition panel include this default variable grid. One of the elements of this grid is the subject identifier variable. By default, the value is set to default, which means that Explorer will try to find a variable called ID in your dataset. If it does not find the ID variable, it will not know what a subject is, and your profile will actually fail because KIWI cannot really identify what a subject is and cannot really filter to the first record of a subject. So if you don't have an ID variable in your dataset, you can select another variable that could be defining your subject. So in my case, I'm going to select ID, which is going to be the same result as leaving the value to default. Going to let this profile rerun. The next profile had a slight different definition. I used the last record per ID filter, and in this case, the plot looks a little bit different, with obviously higher value of the TSFD, because those would be the last record in each subject, so the highest value of TSFD. To illustrate the other 2 filtering method based upon combinations of the subject ID and covariables, I will switch to another page of the user manual describing the subsetting data functionality of KIWI Explorer. The two remaining methods really are really only useful when you're trying to subset data that had time varying covariates, and I will illustrate the reason why next. So here we have a little table showing the content of a very simple data set with three records, three subjects, and two KIWIs, KOV1 and KOV2. This would be the data subset that would be used if you use all records within the subset filter. This second and third column describe the result of applying the first record per subject filter or the last record per subject filter. The other two filters combine subject ID and covariable. The first one requests the exclusion of duplicate combination of subject and covariable value. So any duplicate combination of ID, KOV1 and KOV2 will be recognized in this dataset and excluded. So if you're looking more specifically at subject 1, subject 1 had a duplicate combination of KOV1 and KOV2 on record 1 and 3. Record 2 and 4 have either a different value of KOV2 and in the case of the last record, different value of KOV1 and KOV2. So for this first subject, this particular filtering method will exclude the third record, and you will end up with only 3 records for this particular subject. The last method is slightly different. It's requesting the exclusion of combinations of subject and covariable that repeat themselves. So going back to the first subject, even though you have duplicate combinations of the ID and KOV1 and KOV2 variables, these duplicate record actually happen after a change. So this record combination is different from the second combination or the second record. The combination on the third record is also different from the combination on the second record, and the same applies for the fourth versus the third. So at the end of the day, for the subject 1, you end up not excluding any record using this no repeat method. If there were additional records between the third and the fourth that kept the same combination of KOV1 and KOV2, those repeated combination would be excluded. Going back to the application, I will now illustrate the use of the last method, which involves the exclusion of BLQ records. I have a line plot showing the concentration versus time for the subject including in my first study and who received dose 10. You can see between I would say 6 to 8 subjects in this plot, and the red line displays the value of or represent the value of the LLOQ or fictitious LLOQ in this case actually. If I go back to my scatter plot and select this no exclusion of BLQ record, you can see that the top right panel contains this new BLQ handling option. When you open that panel, the panel contains 4 fields. A separate tutorial will go over all those 4 fields. For the purpose of data subset, I will only talk about the first 2 fields. The default handling method of BLQ records is to do nothing. Basically, we don't exclude records based upon BLQ. You can select 4 different methods of handling BLQ. Only one of those methods will result in the exclusion of data, so the filtering of data, which is this second option, exclude. I'm not going to change that selection for this particular profile. I will just now show the application of an exclusion of BLQ. On this profile, you can see that now the concentration are only, the plot shows only the concentration above the 80, the 20, I guess, nanogram per ml. Any record below that threshold is excluded, and this resulted in the x-axis being a lot shorter than in the previous profile. So how do you obtain that exclusion? Again, you go to the BLQ handling panel for the appropriate profile. And in this panel, I have selected the exclude handling method, and I had to provide a BLQ variable. So this would be a variable that flags or identify the records that are below the LLOQ and those that are not. This variable must be a numerical variable. The records that are associated with a value of 0 are considered not to be BLQ. Any other value, whether it's a positive or a negative value, will be considered a BLQ record. So again, by excluding the records based upon the BLQ-FN, we will keep only the record that have BLQ-FN equals to 0. So as I mentioned earlier in this presentation, those three methods can be combined to subset your data. So you can combine a global data subset with a BLQ method, which is actually what I've done here. I have a global data subset expression that was defined here in combination with the exclusion of BLQ. So this concludes our presentation of the method of subsetting data in KIWI Explorer. Thank you.